Alright, welcome to this lecture. This is How Fast is Too Fast. The quote we have here is the way to catch a knuckleball is to wait until it stops rolling and then pick it up. And so what we're going to be doing in this lecture is that we'll learn how to create and interpret a distance versus time graph, how to create and interpret meaning how to read it, how to get information from it, and then we're going to use the equation speed equals distance all over time. So jumping right into this, what we should already know. What we should already know is that the length between 2 points can be measured using either distance or displacement, and they're two different things in some cases. For objects moving that do not change direction, distance equals displacement, but that's not always the case. We know that they change direction and everything else, and so distance doesn't always equal displacement. So what we learned in the lab, time is usually the independent variable. In this class, generally it's always going to be the independent variable, and distance is the dependent variable. And the slope of a distance versus time graph gives a speed, which, remember, again, slope is y2 minus y1 over x2 minus x1. And so jumping into it, what we see, time is measures the intervals between events. It's measured with a photo gate, and we could either use a photo gate or we can also use a stopwatch. So a photo gate or a stopwatch we can measure time with, and it's nearly always the independent variable. Generally in this class, it's always the independent variable. Distance versus displacement. Now, distance is scalar, meaning that the total length traveled between 2 points. Scalar meaning it just has a number with it. And so we can think of this as if we start right here in the line and we travel all along this line all the way to the stop. The distance would be the entire thing that we traveled. You can kind of think of distance as if you ever use like a Garmin watch to run, or if you use your iPhone to calculate your running. That's distance. It's the total traveled. Now the displacement, it's a vector measuring the change in position between 2 points. So the vector would be from start to stop. And both are measurements of length, and they're measured in meters. Another way to think of it, distance, if you plan a trip and you put the coordinates into MapQuest, MapQuest is going to give you a distance that you're going to travel. If you look on a map and you draw from where you're starting to where you're finishing and you measure that, that's going to be your displacement. And so two different things. Now, making a graph, and we really want to make a graph. Graphs are very helpful and useful information. So the steps in it. First, we have to identify the variables. That's step one. And we identify the independent variable and the units. So when we're talking about distance and time, distance is going to be our independent variable, and our time normally is going to be in seconds. The independent variable is the variable that you change. We change the time. In the dependent variable, we have to identify that and its units. So in this case, we're talking about distance or displacement, and so we're talking about that, and that's going to be in meters. And so the dependent variable always goes on the y-axis, and the independent variable always goes on the x-axis. So after we identify what the independent and dependent variable is, we then make a title, the graph, using the following conventions: dependent variable versus independent variable for this investigation. For example, distance versus time for walking investigation. And so that would go at the very top of our graph, and that would go there. Okay. Step 3 is scale the graph, and so we want to scale the graph. So what we do is we identify the maximum and minimum measurements. So if we're talking about, we start, our minimum measurement is 5, our maximum measurement is 10. Those are our minimum and maximum measurements. And what we do is we count how many boxes you have on each axis. So literally we sit here and we count those boxes and then count those boxes. And what we do is we take our maximum, which say it's 10, minus our minimum, which is 5, all divided by the number of boxes. So we have 20 boxes here, so if we do 10 minus 5, that's going to give us 5. And we all divide that by 20, we'll get 0.25. And so what that would mean is that means that our scale would be 0.25 per box. Okay, and so we put all the data points on the graph. After we find the scale and we make sure that we put their scale and we write it in, we go ahead and we put all the data points on the graph. And what we'll see is we'll probably have some data points that really line up really well. And so we line everything up and we put our data points on the graph by using our numbers that we write in here when we write our scale. And then we draw the line. And so when we're looking at this, we draw one straight line that goes through an average of the points. So if we have all of these dots, what we don't want to do is come in through here and just go connect the dots. We never connect the dots. What we want to do is we want to draw one line that goes through as many of the points as possible. And what this does is it will give us an average. And that average is important. So the last step that we have is we can find the slope. Look at the line, not the data points. So pick 2 points. So once we get our line that's nice and straight, we pick 2 points that are easy to read and we calculate the rise over run for the 2 points to get our slope. And the slope is actually really important. Calculating the slope is just not for fun. The slope has a meaning. In this case, our rise is our dependent variable, which is our distance, over our run, which is our time. So our distance over time, if we calculate the slope of the line, that gives us speed. So let's look at an example. So on our first example, it says a student investigating the relationship between distance, a toy car, and time it is allowed to roll along the floor. What would be an appropriate title for the graph? So what we could say is that distance versus time of a toy car investigation. And that would be a good title for that graph. Looking at our next example, it says determine the average speed of an object based on the graph. And so what we see here is we see a perfect correlation where that average line goes right through all of them. And so what we're going to do is try to find the average speed. Well, what does slope give us? Slope gives us an average speed. So let's pick 2 points on here that are really easy to read. Well, one point right here, that's 0, 0. And then we can pick any one of these points. Let's say that we have here, which is 10, 10, or we could use 1, 8, 8. So let's go ahead and let's pick 8, 8. And so what we do is we set it up in our equation. Our slope equals our 2 y's, so y2, which would be 8, minus y1, which is 0, all over x2, which is, we look at our x, that is 8, minus x1, 0. And what we'll see, 8 minus 0 and 8 minus 0, and then we go 8 minus 8, that will just give us 1. And if we think about it, this is 8 meters, this is 8 seconds, so our unit for this is going to be meters over seconds, or meters per second. Looking at our next one, it says how far will the car be at b seconds? So if I look at b seconds, I go all the way up, it's right there, and then all I have to do is look over, and I can look and see when I look over that the car will be 24 meters from the start, from the origin. Okay, and so I can find the distance in meters just by reading the graph. Now let's look at this one. It says determine the average velocity between 4 and 5 seconds. So 4 is right here, 5 is right here. And the one thing we can think about on this one's a mastery level question. It's a hard question. When we look at this, what we can think is that we're going to find between here, and they're really close. That average is really close, and it's close to a straight line. So what we can do is we can go ahead and take this, and we can find the slope of that line, and that will give us the average velocity, because that's our position, time, meters, seconds. So we go ahead and we take this, and when we're looking at it, this is right around 16. If we kind of go over here, we'll say that that's 16, and then when we look down here, that is 4. And we look at this one, this is 25, and we look down, that is 5. So what we will do is our slope will equal 25 minus 16 all over 5 minus 4. So when we look at this, 25 minus 16 is going to give us 9, and 5 minus 4 is going to give us 1. So what we'll have is we'll have 9 meters per second from 4 to 5. Now, when we're looking at this, we see that it's not a straight line, but we see that it's kind of curved. So what can we say about that? Well, we know that the velocity is going to be changing through the whole thing. Looking at another mastery level question, it says, what time interval will the object shown below be moving the fastest? And so what we can think is, well, we know that speed is slope. Well, in what case is our slope the greatest? And we can actually see that our slope will be right during the 16 to 18 seconds. That's the greatest slope that we'll have. Now, average speed, what we've been calculating on that graph, it's the relationship between speed, distance, and time can be seen in the equation speed equals distance all over time. Now, we don't have to use a graph for every set of data to find the speed. Sometimes we can just calculate it if we have the variables. So when we're looking at this, speed is the distance over time. Velocity is displacement over time. So if we're talking about distance over time, we're talking about speed. If we're talking about displacement over time, we're talking about velocity. Speed and velocity are the same unless the object changes direction. Okay? And normally in this class they're going to stay the same. So this is speed and this is velocity. The only thing that's really changed is it distance or is it displacement? So here's the equation that we have for speed, and we'll generally just talk about speed, just talk about moving in one direction. And so we have speed equals distance all over time. Speed is the rate of change in distance. It's measured in meters per second, and we can use this using a photo gate and a ruler or a lovely radar gun. Distance is the total length traveled measured in meters with a meter stick, and time is the interval between events using a photo gate or stopwatch. And here's our equation. So when we solve everything out, we like to use what we call the guess method. So the given, which is the information the problem provides, the unknown, what you are solving for, the equation, we write out the equation with no numbers, substitution, we put in the numbers in the equation, and then we solution, we solve for the unknown. So fill in the words and meaning for the acronym below. Guess, which we just did that, which that stands for our given, which is the information provided, unknown, what you're solving for, equation, write the equation with no numbers, substitution, put the numbers in the equation, and then solution, solve for the unknown. When do we use guess? Whenever there is a calculation involving a formula, we want to use the guess method. So let's go ahead and jump into some examples. Match the units with the variable and circle the units if they need to be converted. So when looking at this, distance is measured in meters. We know that S stands for speed, and a speed would be miles per hour, and time, minutes is time. And what needs to be converted? Well, we know that speed needs to be in meters per second, and we know that time needs to be in seconds. So those are two things that need to be converted. Let's look at the next example. It says a car is traveling down a long, straight 200-meter road for 10 seconds. What is the average speed of the car down the road? So we use the guess method. Our given Our given is going to be that we have a 200-meter road. Our time is going to be 10 seconds. Our unknown is going to be speed. Okay, the equation that we're going to use is speed equals distance all over time. There's our equation, and then we substitute everything in. So speed equals a distance of 200 meters all over 10 seconds. And then we go ahead and do our solution and solve everything out, which we get 200 divided by 10 is going to give us 20 meters per second. Looking at our next one, it says a student walking down the hall has 5 minutes to walk 150 meters to the next class. What is the minimum average speed the student can have and make it to the class? Answer in standard units. So when we're looking at our given is 150 meters and then 5 minutes. So our time is 5 minutes. We need to convert it into seconds. So how many minutes are in a second? Well, 60. So 5 times 60 is 300 seconds. Our unknown, we're solving for speed. Our equation, speed equals distance all over time. Substitute everything in. Our distance is going to be 150 meters. Our time is going to be 300 seconds. We solve it all, and we'll get 0.5 meters per second. Now let's look at a mastery level question. It says you wake up late for school one morning and walk out the door at 8:36 a.m. You travel at an average of 45 miles per hour for the 11-kilometer trip. If the school starts at 8:45 a.m., will you be on time? Very tough question. So we got to look at what we're given. We're given S, which is speed, in 45 miles per 1 hour. Okay? And then we're also given the distance as 11 kilometers. And it's also giving us a time, which we have a time of 8:45 is when we have to be there, and we left it 8:36, and so therefore we have a time of 9 minutes. And so to figure out if we're going to be on time, we need to look at how long it will take us to travel those 11 kilometers. So when I'm looking at this, I can look at it, and what I can think is I need this in meters per second, my time, or my speed. And so to convert this, it's a pretty hard conversion. In 1 hour, there's 3,600 seconds. And in 1 mile, there is 1,600 or 1,609 meters. So I have a speed of 20.1 meters per second. That's my speed. Now all I need is just meters. How many meters? Well, there's 1,000 meters in 1 kilometer, so that means that this is 11,000 meters. Okay, so when we're looking at this, what we can say is we can say that speed equals distance all over time. We're trying to figure out how much time it takes. So if we rearrange this equation algebraically, what we'll get is we'll get that time equals distance all over speed. And what we'll see is we'll plug in our distance of 11,000 meters all divided by 20.1 meters per second, and that will give us a time of right around 547 seconds, which when we look at it is more than 9 minutes, so therefore we're going to be late.